Let's dive in and calculate strategic value, and we'll crunch some numbers here. There are three primary measures of strategic value. There is net present value. There is the return on investment. Again, probably the single most important number in business and the one that you should always be able to calculate and always be able to answer someone's question on what the return is. And then there's a notion called payback, or how long does it take to get your money back. We'll talk about each one of these and why that's important and how you calculate that. There is actually a fourth number. It's called the present value of the benefit. It is an intermediate number. We will identify it, we will calculate it, and we will use that in calculating all three of these values. Let's talk about the net present value. The net present value is taking, essentially accumulating all the investments, all the costs, all the benefits, and actually netting them out to come up with what is the value of a particular project in today's dollars. The simple formula is net present value equals the present value of the benefit minus the initial investment. Now, that's, as you can see below, the present value of the benefit is a pretty complicated formula. Let's just walk through it, and then I will step you through how to calculate it. So please don't quite get intimidated yet. Oh, by the way, it would be good if you have a piece of paper and a calculator as we go through this so you can follow along and calculate the numbers with me. If you don't have that, pause here, grab a calculator, grab a piece of paper. This stuff is best learned by actually doing it yourself. Okay, back to the formula. Formula for present value of the benefit is the net gain for a given year, year one, divided by 1 plus the discount rate raised to the power of the year, or raised to the first power. Then you add the net gain for year 2 divided by 1 plus the discount rate raised to the second power for the second year, and so on. Okay, where R is the discount rate and that exponent n represents the year. I'm sure if you're not mathematically inclined, this might be a little daunting. So let's take a breath, let's move on and break this down basically piece by piece. Present value of year one is simply you take the net gain for year one and divide it by 1 plus the discount rate raised to the first power. So the exponent 1 is the year, R represents the discount rate, and then net gain is simply your benefits minus the costs. And we'll walk through an example of that as well. To calculate the present value for year 2, it is the net gain for year 2 divided by 1 plus the discount rate raised to the second power, because now we're in year 2, and so on. So in any given year, it's the present value of the year n equals the net gain for year n divided by 1 plus the discount rate raised to the nth power. So let's see how that breaks out, and we'll again take this step by step and how you might actually calculate this. So first thing you need to do is calculate the net gain. The net gain is simply the benefit minus the cost for each given year. So benefit can be revenue, which is a pretty good one. It can also be cost savings. It can be a combination of both. But you want to take the good value that your project yielded, revenue, decreased cost savings, etc., and subtract out the cost that it takes to get that benefit in each year. And that gives you the net gain. Okay, so let's take a look at a simple example. So let's say we have a project. For the case of simplicity, we will say that the benefit in this case is an increase of revenue in year one of $300,000, in year two $600,000, and in year three $800,000. The ongoing cost of this particular project for each year is $100,000 in each of those 3 years. So the net gain is simply subtracting the cost from the benefit. So the net gain in year one is $200,000. Simple math. Net gain in year 2, $500,000. Net gain in year 3, $700,000. So then what we need to do, as we've said before, is that those future dollars, those future net gains, we have to discount those back to our present day, to the day that we're starting the project. These are all projections. We have to say, well, that $800,000 that we're going to earn in year 3 is not really worth $800,000 as we sit today. What we have to do is we have to discount each of those net gains back to present day dollars. We're going to use a discount rate of 7%. So what we're going to do is we're going to apply the discount rate for each of those net gains in each of those 3 years. And so follow along with me here. To calculate the present value of year 1, we're going to take that $200,000 net gain and we're going to divide it by 1 plus the discount rate, then the discount rate of 7% expressed as a decimal, so 1 plus 0.07 raised to the first power. If you do the math, you should come up with the number shown here, $186,916. Present value in year 2, you take the $500,000 net gain. Now you're in year 2, so you take 1 plus the discount rate. Now you raise that to the second power, and you should get the answer, the discounted rate of $436,719. So that $500,000 is actually worth $436,719 in today's terms. And so you do that all the way across. In this table, you come up with the discounted net gains for each of the 3 years. Then what you need to do is simply calculate the present value of the benefit. You take each of those discounted net gains for each of those 3 years and you add them together. And in this case, when you add them together, you get $1,195,044. That is the present value of the benefit. Write that number down. That, as I said before, is an intermediate number. We will use that again. To calculate the net present value, you have to take present value of the benefit and you subtract from that your initial year 0 cost or your initial investment. Year 0 is at the very start of the project, what you need to invest in that. You subtract out your initial investment, in this case of $400,000, and you come up with a net present value of $795,044. That is, in fact, the present value, the net present value of your project. That is how much value your particular project adds to the firm expressed in today's dollars. So, and let's talk a little bit more about what you can do with that. Your particular project added $795,000 or will add $795,000 of value to your company, to your organization. First of all, it's positive. That's good. It's well worth it. You can also use that to compare against other projects that are competing for your attention and time. Or let's just say you only have $400,000 to invest in a particular project. You only have $400,000, and what you want to do is you want to say, what's the best value for that $400,000? Investing the $400,000 in this particular project will bring back to the firm $795,000. There might be other projects that yield a higher net present value, that provide more value to the firm, and some that might provide less. So you can use that net present value as a comparative tool to compare projects. And the whole reason discounting is important is you may have a project, in this particular case, instead of what we laid out in terms of $200,000 and $500,000 and $800,000, let's say it's all back-end loaded. Let's say you invest right now that $400,000, but you're not going to see a return for 5 years, but it might be $1 million. It might be $2 million. Don't know. The fact of the matter is that $1 million doesn't come out until much further out into the future. Again, it turns out, even though the absolute dollars might be higher, using the whole concept of the time value of money, that might actually yield less benefit to the firm. Understanding the whole time value of money and when the money actually is available to the firm is also critically important, and that's another reason why we discount future benefits so that we basically are able to compare apples to apples when comparing projects. Let's move on. Let's calculate that most important number, return on investment. Actually, you did most of the heavy lifting already. The return on investment is you just take that present value of the benefit, that intermediate number I asked you to write down and save, and you divide that by the initial investment, and then, of course, you multiply the results by 100% to express that as a percent. So in this particular case, the present value of the benefit was $1,195,044. We divide that by the initial investment of $400,000 and come up with a return of 299%. Almost 300%. We almost triple our money that we invested into the project. 299%? Pretty good return on investment. Would do that project all day long. The last one is payback. And payback is how quickly do you get your money back? This is a pretty dangerous calculation for reasons that I'll explain here second. But let's just do the mechanics. So here, what you want to do is you take the initial investment and you divide it by the present value benefit of your gains, so the present value of your benefits, and divide that number by the total years in the planning horizon. So basically you come up with what your average present value of the benefit is over the time of your project. You simply do the math and you take that $1,195,044 divided by 3. So the average present value of the benefit over the 3 years is $398,348. Divide that into the $400,000 initial investment and you'll see that, and actually it's about 1 year, a little over a year payback. Danger here. Payback when you have an escalating benefit may in fact give you the wrong answer. Because if you were to look at the schedule in that spreadsheet, you can look and say, oh my gosh, there's no way that this pays back in the first year. That's part of the problem with the whole payback calculations. This is kind of the back of the napkin version of payback. There are other more sophisticated ways to calculate payback which take into account escalating benefit. Those are outside the scope of this course. But oftentimes people will do payback in this particular format. Be aware that sometimes it gives you the right answer, sometimes it doesn't. Where net present value and return on investment are always good numbers with respect to comparing projects, payback has a lot of danger in it. It's good to know how that it's calculated, but beware that it really only works in the simplified form where the benefits are even throughout the planning horizon. If they escalate like they did in our example, you will in fact get a bad answer. Be careful there and watch out for payback. And so let's take a look at that another way to calculate payback. And it's clear from the example that we provided that the present value of the benefit escalates year over year. And even though in the previous calculation we calculated that the payback was in 1 year, you can look at the present value of the benefit after year 1 and compare that to the initial investment and say, that's not right. This is somewhat of a crude method of calculating payback. I think you can see the simplicity here. So what you can see is that right off the bat, the initial investment is not paid back after year 1. So we can do that calculation fairly easily and show that after year 1, there's still $213,084 of the initial investment that haven't been paid back by the present value of the benefit. But what we can also see that the present value of the benefit in year 2 more than covers that residual amount of initial investment. So what we can simply do to calculate or come up with what the payback period is take that residual number and divide that by the present value of the benefit in year 2 and come up with 0.49. And then we simply have to add the two numbers together, the fact that year 1 plus 0.49, and determine that in this case that the payback is in 1.49 years, so a year and a half. And that's significantly different than the 1 year that we came up with the formula that we used before, which assumes a constant and consistent present value of the benefit year over year. So that's usually not the case. Generally what we did is we see, based on the cumulative present value of the benefit, when about does that initial investment get recovered, and then whatever that residual amount is, divide that by the present value of the benefit in that last year where you know that ultimately it's going to get covered, and come up with the overall payback period. There's an assumption here as well, and the assumption I made is that in year 2, that present value of the benefit, that $436,719, is earned uniformly over year 2. That might not be the case either. And again, with the magic of spreadsheets in Excel, you can actually come up with a much easier way to calculate a more precise payback. What I would say about payback in general is that return on investment and net present value are always a much better indicator of a project's value than payback. So keep that in mind as well. So we're going to leave it here, and we'll walk through some more examples and actually show you how to set all this up in Excel.